Hello all, today in this video we are going to make an demo for linear kernel SVM with regularization as 100, that is C is equal to 100. Previously we have worked with C is equal to 1.0 and C is equal to 10.0. When working with 1.0 we have got the same accuracy when we worked with the linear kernel without any change, but when working with 10.0 we got some deviations, but it is less than that of the less than the original linear SVM. Now we are going to work with a linear SVM with regularization as 100. In that case also we are getting the same as the linear kernel without any regularization. This shows that mostly it will not have any as much difference. Maybe with this data set it is not showing as much difference. Some cases it may show some difference. So for that initially we are importing the library and it's calling our data set. This data set I downloaded from Kaggle. You can simply give it as hard disease detection Kaggle data set. Means you will just get the data set and you can download and use it. It is having nearly 14 rows and columns. Among that the first 13 columns we are using as the x variable and the last one we are using as the y variable. Then we are getting the info of the data set, whether it is integer or float. Then we are checking whether our data is having any null and entries. Since it is not having any null entries, we are not working with any pre-processing function. If it is having any null entries, means we have to work with pre-processing. Then we are getting the shape of the data set. Then we are making a plot. In this plot we are using the target variable, and also we are making the value counts that the target variable is having nearly two classes like 0 and 1. Among them we are making and count that which classes is of higher count, and based on that we are making a graph plot. Then by using the train test split function and by use of the x variable and y variable with the test size of 0.2, that is 20% for testing and remaining 80% for training, we are determining variables like x train, x test, y train and y test. Then we have worked with the linear kernel. For that we are importing the SVM library, and within the SVM library we are calling the kernel as SVM, and then we are training the SVM by using the fit function and the training variables, and then we are testing the SVM by using the predict function and the testing variables, and then we are declaring a predict variable. This predict variable we are using to plot the confusion matrix and also to display the classification report parameters like precision, recall, F1 score, support, accuracy, macro average and also weighted average, and we have got an accuracy of 80%. Then we have also worked with sigmoid kernel, and then we are using the fit function for training and predict function for testing, and then we have displayed the confusion matrix and also printed the classification report parameters and have got an accuracy of 58%. Then we have worked with the radial basis function, and we have trained the model by using the fit function and tested the model by using the predict function, and then we have plotted the confusion matrix and also printed the classification report parameters and have got an accuracy of 61%. Then we have made the polynomial SVM demo, and then here also we have the use the fit function for training and predict function for testing, and then displayed the confusion matrix and also printed the classification report and got the accuracy of 64%. Among the four kernels we have got in this particular data set, a linear SVM kernel is providing better result. So with this linear SVM kernel we have worked with the regularization parameter C. First we worked with the Z is equal to 1.0. At that case we are getting the same accuracy for which we got the linear kernel. Then we worked the regularization parameter as 10. In that case we have made some changes changes, but it is less than when compared to the original SVM kernel. Previously it was 80, now it was 79 only. So we worked with the 100. In that case we got no, in that case also there is no change because we got an accuracy of 80% only. So based on that we have made an comparison plot. So in that comparison plot you may notice that we have got an uh, here it is 80 only, but when plotting the confusion matrix you may notice that we are making some it is showing some changes. That is the regularization parameter 100 is showing better accuracy than the linear kernel, and the linear kernel with the regularization parameter c is equal to 1.0 and 10.0. So the least model is the sigmoid. We have made a table comparison. So this is the thing. In the next video we will be making some other demo video. Thank you.